Remember I said that we can view quadratic expressions as rectangles. Its factors can be seen as the lengths of the sides of that rectangle, and if its factors are the same, then we can even see it as a square. For example, if I had a quadratic expression that I factorized to be x plus 3 all squared, then that means each side of that square would be x plus 3. What if I had an expression like x squared plus 8x? Could I put it together as a square? Well, I could split the 8x evenly to put 4x on both sides, but I would still have a missing section. So how much units would I need in that empty space to make it a perfect square? Look good. It has a height of 4 units and a base of 4 units. So if I put a 4 by 4 or 16 unit squares, it's now a perfect square with sides x plus 4. So in a sense, we could have said that I just completed the square. I just added some units to make it a perfect square. Now this idea, this concept is the basic idea behind solving quadratic equations. As a matter of fact, it's where we got the quadratic formula from. It's a very useful technique. Let's see how it works. So I want to use it to solve this equation, p squared minus 10p minus 4. Now, as soon as we say complete the square, we know that we'll need a number that is going to make this expression the perfect square. So I need to figure that out. So to do that, I think I'm going to try and draw it, to make sense of what's going on here. So I have p squared minus 10p. I could think about this as p squared. And for negative 10p, now we know we can't have a negative length, but we can think about negative p like a different kind of tile. That is, if we said that p was, a yellow tile, then we could think that negative p is like a red tile. So by doing that, that means I need to split negative 10p in half. And that means I'd have 5 tiles up here. And I'd also have 5 tiles down here. And now I almost have my perfect square. The only thing I need is to figure out how many units do I need to put in this empty space. Well, if this side is negative 5, and this side is negative 5, then this missing space would be negative 5 times negative 5, which would be positive 25. So that's what I need to put in my expression to complete the square. So it would be p squared minus 10p plus 25. So I'm going to put back the rest of my equation. So I'm going to put back my negative 4. And remember, because I added 25 here, my equation isn't balanced. So to make it balanced, I need to put a 25 on the other side. So that means I'll need to write back a plus 25 over here. Now my equation is balanced. And doing that, then I can complete the square of my expression. Because when you look at my expression here, p squared minus 10p plus 25, that's the perfect square of p minus 5 all squared. And visually that makes sense, because if you look back on our completed square here, notice that this would be p, this would be negative 5, this would be p, and this up here would also be negative 5. Let me just draw it in right here. So it would be p minus 5 times p minus 5. So if that's the case, now I can group like terms. P minus 5 is going to be squared, is going to be equal to 25 plus 4, which is 29. And if that's true, that means I can solve for p, because all of this side is squared. So if I root both sides of the equation, so if I square root here and square root here, that will get rid of the square and leave me with p minus 5. And if I get my calculator, then 29, the square root of 29 is 5.38 something something. But remember, I only wanted my answer to 2dp. I'm solving it to 2dp, so I only need 2 decimal places here, which would bring it to 5.39. So p minus 5 is equal to plus or minus 5.39. And if that's true, that means I can again do some transposing, so I can carry my negative 5 over here. So that means p is equal to a positive 5 plus or minus 5.39. And plus or minus tells us that p is going to either be equal to 5 plus 5.39 or p is equal to 5 minus 5.39. 5 plus 5.39 is 10.39, and 5 minus 5.39, I think it should be negative 0.39. Let me just put that back in our calculator to make sure. 5 minus 5.39, yes, it would be negative 0.39. Now, do you notice a pattern in finding that special number to complete the square? In each case, we had split the variable in half, and then we squared that term. In this case, p squared minus 10p plus 25, we split 10p in half, which is what gave us negative 5p, and then we squared it to get positive 25. And you notice that same number always ends back up in the completed square. Now, because we realized that pattern, we don't always need to draw, because whenever we want to find the number needed to complete the square, all we need to do is to halve the coefficient of the variable and then square it. So for example, let's say I was completing the square of another expression like x squared plus 5x. Now, that number that I'd need, this number, let me come over here, this number that I'd need is half the coefficient of x, which would be half times 5, which is 5 over 2, and then I would square it. So that's the number that I need. So to complete this square, it would be x squared plus 5x plus 5 over 2 all squared. Now, in this lesson, I'm going to give you a few more to do on your own, probably 2 or 3, and then we're going to do some harder ones together.